Programmable matter. How much do you really know about it? Do you even know what it is? I, while I was doing the research on this, quite frankly, I have to tell you, there are many of this aspects that I was completely unaware of, which when you see the end of this program, you're going to realize that it's more a part of your life than what you could have ever had thought. So, what is it? Well, I can tell you this, the three tech giants investing in digitizing life. And that's really what it is. It's digitizing life, literal life. And you can see, and there's others. These are the ones that got in early and have spent billions in perfecting this science. So it's not new. Let me just tell you that. This is not new. It's been around for, as you can see, for literally going on close to 30 years now. I mean, that is incredible. So programmable matter is a term originally coined in 1991 by Tofili and Margalos to refer to an ensemble of fine-grained computing elements arranged in space. Now, that alone could take hours just to dissect it. Their paper went on to describe a computing substrate that is composed of fine-grained compute nodes distributed throughout space, which communicate using only nearest neighbor interactions, conservation of energy. In this context, programmable matter refers to compute models similar to cellular autodate and lattice gas automate. So, complicated. Well, what it is in layman's terms is material that can take on any shape. Now, before we move forward, take a good look at this and think to yourself, where have you seen this before? I'll clue you in as we progress. All right, so in the early 1990s, there was a significant amount of work in reconfigurable modular robotics with a philosophy similar to programmable matter. They realized back then that if you could alter the molecules, well, then you could begin to literally program matter, physical matter. So in the summer of 1998, in a discussion on artificial atoms and programmable matter, Will McCarthy and G. Snyder coined the term quantum wellstone, or simply wellstone, to describe this hypothetical but plausible form of programmable matter. Now, McCarthy went on to use the term in his fiction, in his books. So, isn't it odd how it starts with a thought? The thought leads to, well, what we would call fiction, science fiction, and yet it ends up being proved to be true. Now, what really changed this was when DARPA got involved, and that was in 2007. And from there, it has, well, exploded. So take a look at this. So everything is, well, it's a building block, a cube. Consider that, everything. So programmable matter is matter which has the ability to change its physical properties, shape, density, modular conductivity, optical properties, you just name it, in a programmable fashion based upon user input or autonomous sensing. Programmable matter is thus linked to the concept of a material which inherently has the ability to perform information processing. Think about that everything, your body, stop and look at your hands right now while you're listening to me. Your hand is made up of billions of molecules. The cohesion allows them to form density. And by the command input of your mind, which then is translated to your brain, then your nervous system, your body, in essence, is a programmable matter of which you give the instruction to. You see how easy that is? Now, the concept continues, and programmable matter can be based on simple programmable matter, complex fluids, metamaterials, shape-changing molecules, permanent magnets. Now, we're going to get into each one of these because it helps when you begin to see that it's really not this complex science. No doubt, the science is complex. But basically to apprehend the concept, it gets pretty simple. So look down here at your lower right-hand corner. So imagine a room is where you live. You're given basically an 8 by 10. All right, let's get a little bit more generous. We'll give you a 15 by 20 livable space. But all the material in this domicile that you live in is programmable matter, which means you don't need furniture anymore. You don't need plumbing. You don't need anything that takes today to build a habitat, because the matter can be programmed. You want a bathtub, bathroom, you program the matter. You want your bedroom, you program the matter. You see where this goes? Interesting concepts when you begin to really carry it out. So, it's much more complex, but yet pretty simple when you really begin to think about what the applications are. So I asked you the question previously, where have you seen this before? Roswell. Remember the craft? Remember the material that Marseille's showed? The kernel? Programmable matter. It can be ultra thin, but absolute dense, and take the shape of anything, hold that shape, but can be reshaped. Imagine the applications of being able to do all material like this. You literally could build anything out of nothing. Every human being could have a home. And it goes further. It goes so far down on the molecule level that it is absolute infinite. So here's just an example. If you ever go out now into the malls or the city centers and you see new architecture, look at it. That's what this is. It's in the concept of taking on the shape. So we talked about some elements of programmable matter. Well, first of all, Understand the term simple. Now, these include materials that can change their properties based on some input, but do not have the ability to do complex computation by themselves. All right? You know, it's kind of like you put into the keyboard and you can get what we would call a robot, give it a command, and it thus responds. Complex fluids. Now, that's the physical properties of several complex fluids can be modified by applying a current or voltage, as is the case with liquid crystals. Now, we've all seen that. You can go in there and see the ferrofluids that they now have. We're learning how sound vibration can alter fluids, can make them dense, make them pliable. It's quite interesting to see what we're learning. So when you look at the carbon nanotubes, now this is nanotechnology, programmable matter. Now, metamaterials. Metamaterials are artificial composites that can be controlled to react in ways that do not occur in nature. One example developed by David Smith and then by John Pendry and David, I think that's Scurry, is of a material that can have its index of refraction tuned so that it can have a different index of refraction at different points in the material. If tuned properly, this could result in an invisible cloak. Well, guess what they have today, folks? The military has it. Yeah, private sector now has it. This is no longer theory, this is now fact. Shape-changing molecules. An active area of research in molecules that can change their shape as well as other properties in response to external stimuli. These molecules can be used individually or in mass to form new kinds of materials. Now, this begins to solidify what programmable matter is. It gets better. So we were introduced to this back in 1984. The Terminator. Yeah. Isn't it amazing how science fiction now is science fact? We now understand, even through 3D printing, how everything comes down to simple components. Now, electropermanent magnets. Wow. I had not heard of this before, but this is truly amazing. So, an electropermanent magnet is a type of magnet which consists of both an electromagnet and a dual material permanent magnet, in which the magnetic field produces an electromagnet is used to change the magnetization of the permanent magnet. The permanent magnet consists of magnetically hard and soft materials, of which only the soft material can have its magnetization changed. When the magnetically soft and hard materials have opposite magnetizations, the magnet has no net field. And when they are aligned, the magnet displays the magnetic behavior. Wow. Now this has, well, propulsion systems. I mean, defense systems, shield systems. I mean, there's just an unlimited, again, when you apply this property of programmable matter, look what it opens up. Now, the principal programmable matter is an ensemble, again, of fine-grained computing elements arranged in space. A computing substrate that is composed of fine-grained compute nodes. Got it? Artificial atoms. This is what is the byproduct of this. We are now bringing into existence artificial atoms. Oh, this is a game changer on many different levels. Now, here you can see how we take material science, programming molecules, we take that into the bio-nano, synthetic biology, virology, molecule and cell biology, tissue organ engineering, programmable materials, bio-inspired MFGs, which are then go into the environment. So now you can begin to see, if you have the intelligence, the knowledge, how you could become like a god or be perceived to be a god because you had the knowledge of arranging matter, programming it. Let that one rest on your noodle. Now, robotics-based approaches. Now you're going to see how AI is building the perfect construct. So, what these robots do is they learn from each other. And as they learn, they pass it on to the next component. They can refigure themselves, they can repair themselves, they can disconnect themselves, they can be lost and find themselves. And they learn, 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 learn. They never stop learning. Now, self-reconfiguring modular robots. Self-reconfiguring modular robotics is a field of robotics in which a group of basic robot modules work together to dynamically form shapes and create behaviors suitable for many tasks. Like programmable matter, these units aim to offer significant improvement to any kind of objects or system by introducing many new possibilities. For example, most important is the incredible flexibility that comes from the ability to change the physical structure and behavior of a solution by changing the software that controls the modules. I mean, you'll never have a situation like in Star Trek, the Kobayashi Maru, right? There would never be that situation because the software, the program, rewrites itself. It adapts itself. It has the ability to self-repair by automatically replacing a broken module and will make the new module incredibly more resilient. Now, this is reality, folks. And this is what the material actually looks like. This is its learning by taking shapes, and this is wild. This is AI learning to color, learning to create shapes. Yeah. Now here's one of the robots. This is one of these modular robots. Learns. And the more it learns, it passes on. So self-replication. Now this is another advantage from the nanotechnology is self-replication. This is where one nanomachine will continue to produce new nanomachines with no additional input. This lowers the cost of manufacturing. Now, this has huge implications even for human beings in, repairing organs. Think about in manufacturing. And here is one of the early modules. And it's gotten better now. It can now build itself, its components. Now, Claytronics. Holy cow, Batman. Here's one. Claytronics is an emerging field of engineering concerning reconfigurable nanoscale robots called Claytronic atoms or quantums, designed to form much larger scale machines or mechanisms. The quantums will be sub-millimeter computers that will eventually have the ability to move around, communicate with other computers, change color, and electrostatically connect to other quantums to form different shapes. This is already happening. So we look at the algorithm, right? So here is some applications of Claytronics in designs of, well, for instance, automobiles. So when you think about it, what is Claytronics? Well, let's just say a board meeting with a few executives showing a concept card. They aren't using PowerPoint presentation, but a model that is made out of billions of microscopic bots, like you see in the picture. They are able to manipulate the shape of the car like clay. With the Claytronic model, seems to do exactly what you want it to do. Not only does it change the shape of the headlights with one touch, but it comes apart and change color on command. This isn't a hologram, but something that you can touch and even pick up. Think about this. Synthetic reality. Seriously, folks, what is reality but nothing but a construct of atoms, molecules built upon each other? Now, let's get into synthetic biology. Oh, okay. Synthetic biology is a field that aims to engineer cells with novel biological functions. Such cells are usually used to create larger systems, biofilms, etc., which can be programmed utilizing synthetic gene networks, such as a genetic toggle switches, to change their color, shape, etc. Such bio-inspired approaches to materials production has been demonstrated using self-assembling bacterial biofilm materials that can be programmed for specific functions, such as substrate adhesions, nanoparticle templating, and protein immobilization. Wow. Folks, we are truly living in a different time. So, synthetic biology, what does it mean? Well, it's an emerging field of biology that aims at designing and building new, novel biological systems using our genes. Then you program the cells and it alters it. Wow, you want to talk about a mad scientist doomsday scenario, but this is already happening. Creating a synthetic cell, as described in a report published online in Science magazine, meant putting together a series of previously developed steps. First, the team established a method for transplanting natural DNA, right, from other DNA, then combining those DNAs, and now you have a species whose genome is about half the length of that of the original. Whoa, 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 whoa. Look at this. This is a double helix. This is our DNA. It's being modified. So here's one example of how we could eliminate cholera. As you can see, by introducing an engineered commensal strain into the DNA of the cell, in this case cholera, we change it, we alter it, making it harmless. Now there's the reverse side of this. Just think if something got out of the lab What kind of doomsday scenario do you think that would happen? Now, I talked about the health aspects of it. Think, once nanoparticles are in the bloodstream, they will be able to cross the blood brain barrier. Because of replicating behavior, the nanobots are the big threat of gray goo. Now I brought in the black goo. Let me just say it this way. It's redesigning humanity. It really is. When you begin to see that we're building now a periodic table of 2D artificial atoms, this is a new frontier leading to artificial superintelligence, which we would call the singularity. And this is bringing on a whole new set of issues that humanity must begin to deal with. When you talk about a superintelligence, when you can have a machine to behave like a human, what does that mean for us as a species? I was talking about black goo, so let's talk about it. Well, actually, this thing comes from the use of the term goo was in the phrase gray goo. Gray goo is a mass of small, destructive, self-replicating nano robots. So the word goo simply implies a capability of self-replication. That's what black goo is. That's what the term goo is. Of course, when this was written, most nanorobots will not be capable of duplicating themselves. How we have traveled so far in such a short period of time. This little part concludes saying gray goo has been a major impediment to sensible discussions about nanotechnology. Gray goo may be the reason why some scientists have fought so hard with so little evidence to avoid admitting that molecule manufacturing is possible. Not only possible, it's being done. And mention of biosphere destroying nanobots has appeared all too often in writings ostensibly about near-term nanotech risk like nanoparticles. Hello, anyone for some chemtrails? So here is what goo is. Let's just follow it. First, the assembler is created to convert organic matter into other materials. Then the assembler is programmed to create new units identical to itself. From there, each new unit follows the same programming instruction to consume and multiply. From there, the manufacturing rate becomes exponential, producing greater and greater numbers of assemblers. Finally, eventually, the assemblers would strip the earth of all organic matter, leaving only behind nano machines. Hello, the Borg. White paper dealing on this. It's been around. It's been discussed. It's being done in the lab as we talk. Now think about it. Think about a substance, a substrate, that if it ever touched you, it could immediately enter into you and you would never even know it. And from the gray goo is where we've gotten the black goo. Now, the black goo is said to maybe have come, there's stories about it coming from outer space, or who knows? Who cares? The fact that now humanity has been able to synthesize it in the lab makes it mute as to far where it comes from. Now, Claytronics. You see how this all builds upon itself? Think about this on a molecule level. Each one of these are alive. Synthetically alive, but they're alive. And they can create any biomass that they want. They write their own circuitry, always. Yeah, check that out. We talk about programmable matter. Once the interface is built, it can begin to manipulate from the ether. So how about this? Geoethics is needed for low-risk self-replicating bio nanobots. Folks, this is alarming. Other countries are moving with all haste to actually own this technology. And just look about what it's doing already. We don't realize how much nanotechnology is in the products that you use. You ladies who put on the makeup and what have you, you are using more of this than most males, but now it's turning out that most males are starting to go into this. So I did a program on the NASA thing. Oh, it's been over a year ago, talking about smart dust, nanotags, right? Micro dust weaponry. Think about this, folks. Now you can begin to see how all of this is not just some conspiracy, but actuality. And these were slides that I actually pulled from that. Now you can see how all of this begins to make sense. When you begin to get it, and they have now perfected it down on the molecule level. And look what's coming. Nanotechnology will make anti-aging a reality. It will reverse heart disease. It will create new kinds of foods, longer life foods. You'll never see an out of date anymore. It just goes, Willy Wonka gum. They're really working on this. And so when you begin to look at the nanomaterials, the molecule for self-assembly, and the programmable matter, now you see what programmable matter, why it matters. Creating from the ether. This is coming soon. You're going to be able to hold your smart device and it will project out for you your own system, your own database, your own server farm. You'll be able to create graphics out of thin air. It will be everything that you will need. It will be your God. It will guide you. It will comfort you. It will heal you. And we will go forth with glad and open arms. They're reprogramming things, folks. It's happening. It's here. It's altering our reality. They have brought substrates in from altering realities, creating new realities. Programmable matter. It's everywhere. It's only going to increase. And the substances that we have yet to identify that are unknown to us will alter us even more. The biological supercomputers are here. They have risen. They have now created the singularity. We call it quantum computing. We call it DNA computing. Regardless of what it is altering us, our physical world, and changing humanity.